Hey there, science enthusiasts. Bill Nye here, your trusty guide to the amazing world of physics. Today, we're diving into the fascinating realm of units and measurements. Imagine this, you're baking a cake, but instead of a recipe with precise measurements, you have vague instructions like add some flour or bake for a while. Sounds like a recipe for disaster, right? That's where units and measurements come in. They're the secret ingredients that bring order to the chaos, providing a common language for scientists worldwide to communicate and collaborate effectively. Without units and measurements, the world of science would be like a giant jigsaw puzzle with missing pieces. We need them to understand the universe around us, from the tiniest atoms to the vast expanse of space. So buckle up, grab your lab coats, and get ready for a thrilling adventure into the world of units and measurements. In the world of measurements, we have the International System of Units, or SI units for short. Think of them as the superheroes of the measurement world. There are 7 base units, each representing a fundamental physical quantity. Let's meet them. Meter measures length, the distance between 2 points. Kilogram measures mass, the amount of matter in an object. Second measures time, the duration of an event. Ampere measures electric current, the flow of electric charge. Kelvin measures temperature, how hot or cold something is. Mole measures the amount of substance. Candela measures luminous intensity, the brightness of light. These 7 base units are the foundation of the entire SI system. They're like the primary colors that we can mix and match to create every other color imaginable. Can you think of other things we measure in everyday life that might not use these base units directly? Now that we've met the fantastic 7 base units, let's talk about their equally important sidekicks, derived units. Derived units are like building blocks. We create them by combining base units using mathematical formulas. They help us measure more complex physical quantities. For example, we derive speed, measured in meters per second, by dividing distance by time. Similarly, area, measured in square meters, is derived by multiplying length by width. From velocity and acceleration to force and energy, derived units play a crucial role in describing the physical world around us. Can you think of some other derived units and the base units they're made of? Measuring length is something we do every day, whether it's using a ruler to measure a piece of paper or checking the distance on a map. But did you know that scientists measure lengths on scales both incredibly small and mind-bogglingly large? For tiny objects like cells or microorganisms, scientists use powerful microscopes that can measure distances as small as a micrometer, which is 1/1,000,000th of a meter. On the other hand, astronomers use telescopes and a unit called a light year to measure the vast distances between stars and galaxies. Whether we're exploring the microscopic world or the vastness of space, accurate length measurements are crucial for scientific discovery. What are some tools besides rulers and telescopes that we can use to measure length? Section 5, weighing in. The science of measuring mass. Mass is a measure of how much matter an object contains. We often use the terms mass and weight interchangeably, but they are not the same thing. Weight is the force of gravity acting upon an object's mass. To measure mass, we use different types of balances, from simple beam balances to highly sensitive electronic balances. Balances work by comparing the unknown mass of an object to a known mass. Accurate mass measurements are essential in many fields, from chemistry and physics to engineering and medicine. Can you think of why it might be important to have very precise measurements of mass in certain situations, like baking a cake or conducting a scientific experiment? Section 6, Tick-Tock, unlocking the mysteries of time. Time, it's what keeps everything from happening all at once. We measure time using various devices, from simple sundials that track the sun's movement to highly accurate atomic clocks. The second is the base unit of time, but we also use other units like minutes, hours, days, and years to measure longer durations. Time measurement is crucial for understanding everything from the life cycles of stars to the rhythm of our own heartbeat. From ancient civilizations using the stars to navigate to modern-day scientists studying the universe's expansion, our understanding of time has constantly evolved. Can you think of any events in nature that help us measure time? Section 7, Dimensional Analysis, the superhero of unit conversion. Imagine you're trying to bake a cake using a recipe from a different country. The recipe uses grams for flour and milliliters for milk, but your measuring cups only have ounces and cups. What do you do? This is where dimensional analysis comes to the rescue. It's a powerful tool that helps us convert between different units of measurement. By treating units as algebraic quantities, we can cancel them out and convert them to the desired units. Dimensional analysis is like having a universal translator for units. It's incredibly useful in science, engineering, and even everyday life. Can you think of other situations where you might need to convert between different units of measurement? Section 8, Accuracy, Precision, Errors. Oh my, the tricky trio. In the world of measurements, accuracy, precision, and errors are like three peas in a pod. They're all interconnected and play a crucial role in determining the reliability of our measurements. Accuracy, how close a measurement is to the true or accepted value. Precision, how close repeated measurements are to each other, regardless of their accuracy. Errors, the inevitable uncertainties in measurements that can arise from various sources. Understanding the difference between these three concepts is essential for interpreting experimental data and drawing meaningful conclusions. Can you think of some factors that might affect the accuracy and precision of a measurement? Section 9, Units and Measurements. Your passport to scientific discovery. Congratulations, science explorers. You've journeyed through the fascinating world of units and measurements, from the fundamental base units to the superhero powers of dimensional analysis. Remember, units and measurements are not just abstract concepts confined to textbooks. They're the essential tools that empower us to understand and explore the world around us. So the next time you're baking a cake, measuring your height, or simply marveling at the vastness of the universe, take a moment to appreciate the unsung heroes of science. Units and measurements. Keep those brains curious and never stop exploring the wonders of science. Section 10. Brain-boosting questions. Test your measurement mastery. If you could create a new unit of measurement, what would it be for and what would you call it? Why is it important to use standardized units of measurement in science and everyday life? How do you think ancient civilizations measured time and distance before the invention of modern tools? Can you find some examples of units of measurement used in other countries that are different from those used in your own? Why is it important to be aware of potential sources of error when making measurements? Keep those scientific minds buzzing, and remember, the universe is full of fascinating mysteries waiting to be unlocked.